So, hello everybody and welcome. My name is Maischein and I'm very happy and a bit nervous about telling you what I did in the recent month, generating music using Sonic Pi and OSC. Yeah, what will this be about and how can it be interesting to you? Yeah, hopefully it's interesting because I don't think you will be using this in practice, but maybe you will be using this in practice. This would be fun. If you are actually interested in generating music or listening to some sounds, this might be actually interesting. A warning, there will be sound. At least when we tested it, there was sound, so we have a good chance of it also working during the talk. Yeah, a bit about me. My name is Maischein. I come from Germany in Frankfurt. I work at the DZ Bank in Frankfurt, the Deutsche Zentralgenossenschaftsbank. It's the central bank of the cooperative banks in Germany, and we provide central services for the cooperative banks, and I work there as a digital currency expert on projects, for example, of the ECB, the project of the digital euro, and we also work on a digital currency, the commercial bank money token, which intends to bring money on blockchains of our corporate customers. But yeah, this has nothing to do with Perl. My Perl side is more, I am on the board of a Perl club, the Frankfurt Perl Mongers, and we organize a monthly meeting in Frankfurt. So if you happen to come to Frankfurt, we are happy to organize a meeting with you. And we also organize a yearly Perl workshop where Perl people from all over Germany and other countries come to whatever location we find to talk about Perl, drink beer, enjoy. So what do I want to show, or what will you hear? Well, I want to show a bit of Perl and a bit of open sound control, which is a protocol to talk to sound producing programs. And I will also show a little bit of Sonic Pi, the program I'll be using to create music. And yes, we will hear music. Well, music, not in the polished style of the musician we had 2 days ago, but more like coder music. I'm not really an artist. I can give the computer a bit of things to do, and then I can hope that something nice comes out, but I'm aware of my limits there. So what is my inspiration? The endless acid banger. I will demonstrate that. Sound warning. Hopefully this is not too loud. This is a website that creates an endless acid track. I don't know if you are old enough to have enjoyed acid when it came out first, but it is basically timeless. You plug in some electronic instruments and already you have music, and this can go on forever. No. I understand that acid is not for everybody. You weren't born when acid came out. No, but acid also is not entirely what I want, because if you program stuff and test it out and you'll always listen to some uplifting beat, you tend to get nervous. At least I tend to do that. So yeah, I want something more mellow for that. And also, this program or this website likely works for the guy who did it, because, well, otherwise they wouldn't have done it. But I want more structure and control. This website follows the techno ethic of always forward, never backward. You cannot have things like a verse, then a chorus, breakdown, then go back to the verse again or something like that. And yeah, I prefer my music to have a bit more structure than always progressing and never going back to something that I already know. So yeah, this thing is not what I want, but it's good inspiration. So what can I show you? I can show you or sound off to you some fragments of music, and yeah, I choose the genre of reggae or reggae-ish, or the inspiration from reggae, let's put it that way. It is more mellow and more slow and doesn't have the aggressive parts like acid. So yeah, why do I want to do that? Because, well, I've always been a fan of generative methods, having the computer create endless things that hopefully are somewhat interesting. Generative methods are currently all the rage, but it's the unstructured generative methods, in the sense you put in a real lot of data, let the computer perform some linear algebra, and then you hope that what comes out looks somewhat similar to the data you put in originally. But I find that unsatisfying, because I have to put in so much data when I already know what kind of structure I want to get out. So I want to provide the computer with lots of more guidance than the current generative AI stuff does. So like I said, I want more structure, and to me, music is structured. This is the main draw of music, like having a melody, varying that melody a bit, varying it more, and then coming back to the original melody. That's lots of structure, and I don't want to teach the computer the basic concept of this. I can already teach the computer that directly by writing some code. So yeah, I will attempt the first example. It is dub, because I don't want to subject you to myself singing. Dub means reggae without a vocalist. Well, it means much more. It means a certain set of mix and stuff. Yeah, let's not be too critical of that. We have drums, we have some kind of rhythm and a bass line and a melody, and hopefully we hear some sound. and so on and so on. The melody is not very creative because I cheated a lot when giving the computer instructions on what would sound good with the bass line. But Herbert, you have a question or a remark?
Yes, only about the piece we just heard. Was there any reverb on it?
We'll get to that, to the sound mix and everything.
Not to sound too picky, but a track calling it dub without reverb is lot of confused Rasterman.
Yes, for real dub, I would need to turn the mix far more towards the bass and need to put far more reverb into it. But my fear is that then the reverb overtakes the rest of the generated melody and everything, and I wanted to spend more time on my code than on fiddling with the settings for the reverb and bass filters and everything. So yes, you are correct, this is not real dub, and I would like to get to real dub, but I'm not there.
No, I didn't want to be too picky, but there were hints of that I couldn't quite recognize it. It sometimes sounded like there is reverb, and I just want to
yes, clear. There is a slight reverb, and we'll get to that, but it's not the real reverb you would need to be authentic. So how did I create this fantastic piece of auditory sensation? Well, how do you generate structured sound in general? Well, first you need to create sound, and I'm using something like instruments. I'm not doing the big data approach of putting in lots of noise and then hoping that somehow a melody forms. There are some drum samples and some synthesizer sounds like sine waves that the computer can create easily. And there are some chords that I define with a bit of randomization. And the other thing you need for structured sound is structure. And this means providing some harmonies, and ideally harmonies that follow in a good way on each other. And some more higher level structure like the intro, the verse, the chorus. You want to have some sections in the song. And that's basically external knowledge that I bring into this by writing code instead of having the computer magically figure that out. Now, we've talked a bit already about the reverb. The sound is created by SuperCollider, which is a C program, I believe, and some weird, well, I'm the one to talk about a weird programming language doing Perl, but SuperCollider is another weird programming language. And it does sound synthesis, like, you give it some parameters and it creates a sine wave with those parameters as a sound file. It can also mix in samples and other stuff. And it handles lots and lots of parameters. And SuperCollider is again wrapped by the Sonic Pi program, which is a Ruby program, or has a Ruby interface, another weird language. And Sonic Pi allows me to speak to SuperCollider using a network interface, which makes things so much easier to me. And Sonic Pi also speaks the Open Sound Control Protocol, which is the network protocol, or network protocol that we will use from Perl to speak to Sonic Pi, and Sonic Pi then talks to SuperCollider. So yeah, this is basically the technology stack. Perl speaks to Sonic Pi speaks to Super Collider produces the sound. Sonic Pi, those who were here at the start already got subjected to this. Sonic Pi can do music. It's not really integrated with the outside world, except for the open sound control. But Sonic Pi standalone can also produce sound. And what you here is basically this Sonic Pi program that produces random tones. I'm stopping it because I don't like these random tones. But yeah, Sonic Pi standalone can already do amazing things. But this talk is not so much, or is not only about Sonic Pi. It's also about OSC, the Open Sound Control. This is a protocol that wanted to be better than MIDI. MIDI is the OG of music, electronic music connections and electronic music control. It's a protocol where, yeah, basically every electronic instrument can, as long as it implements MIDI, speak to any other electronic instrument. And Open Sound Control wanted to be better. It is partially better than MIDI. In some respect, it has better timestamps. MIDI has a fixed resolution and Open Sound Control has a higher resolution of timestamps. And Open Sound Control works over standard network cable or even Wi-Fi, while MIDI still basically is serial or serial over USB. So yeah, that's, well, it's nice, but not so great. I have a MIDI, or yeah, you are a MIDI expert.
No, I wouldn't call myself expert, but maybe a nasty question, but this OSC, does it polyphonic aftertouch? Because that's a big battle in MIDI, and why they want to extend the MIDI standard.
Yeah, Open Sound Control is partially better than MIDI. It's also partially worse than MIDI because it has no standards. You get, the good thing about no standards is you get to define your own standards. But the bad thing is none of the devices you speak to will have a basic common set. With MIDI, at least you can hope if you send a note and a volume to a device that claims I can produce sound, it will produce a sound matching that note and matching that volume. Not so with Open Sound Control. Every device can specify its own endpoints, and it does not even declare what kind of parameters and what format of parameters it wants there. So you have maximum flexibility, but basically no interoperability unless you specifically code for the receiver. So yeah, this is how it is. But on the other side, there's a Perl module for speaking Open Sound Control, protocol OSC. And yeah, creating an OSC message is quite simple. Also sending an OSC message from Perl to the network is simple. You create it, you give it the endpoint, the name of the endpoint. In this case, it's /echo. Then you gave it the list of parameters. In this case, we want to pass an integer, a string, and a floating point number. And yeah, then you simply give it all the parameters. That is a 3 in this case for the integer, the word ping for the string, and 3.14 for the floating point number. And yeah, the protocol OSC module gives you then a packed string, and you send that string over the network, and the receiving device does whatever with it. Hopefully it produces sound in my case. Other people have used OSC to control lighting for the stage. So yeah, you will have to study the manual of whatever device you are actually speaking to. There is little convention as to what endpoints and what data a given device will support. Yeah. So we can now produce sound, but I don't only want to produce sound or tones. I want to have them some structure. And yeah, this is then where Perl comes in. I could do most of this directly in SonicPy, but yeah, that's not really my idea of fun. I find Perl more fun. So yes, I want to create patterns, like for example, drum patterns, simply specified as a string, because, well, for drums, well, a real percussionist can produce different tones from a single drum, but not me. So simple plus for now play this instrument, and a dot for don't play this instrument is enough. And yeah, Perl is good in string parsing, so that's easy. And I define the /hi-hat endpoint for the hi-hat, and that's it. Then I also want to create some harmonies, because reggae has traditional harmony sequences. So yeah, I want to reproduce these. And luckily, SonicPy already understands the names for harmonies, so I can tell SonicPy just play a C major chord, and SonicPy plays a C major chord on a given octave for me. So yeah, that's really easy. And faking a bass line is also easy. If you have a sequence of chords, you just take the lowest note of each chord, and that becomes a boring but good enough for me bass line. And yeah, then I also want to create a melody. And yes, creating a melody, the melody is basically random notes in the current harmony, except of course, whenever a chord is playing, I want to choose a note that is within that chord, because otherwise it sounds horrible. And yeah, when no chord is playing, I allow it to play it a random note, but not really random, because I don't want melodies that jump from very low to very high. So it must be like 5 or 6 tones in the vicinity of the last tone played. So yeah, it's really confined to be not too experimental, because yeah, I found when I went experimental, it sounded just too experimental for my ears. So yes. How does this look in code? Well, the setup is basically still like the setup for electronic music. I have a generator that basically generates a long list, a pattern of like, play the bass drum now, play a chord now, play some part of the melody, a note of the melody right now. And then I hand this list to the player, and the player just steps through the list of actions in a given speed and does whatever the list says. So yeah, if we look back to the endless acid banger, it has one, or yeah, the top line is one part of the melody, the middle line is the second part of the melody, and the bottom line is the percussion. And my data structure basically looks the same. I have one array for the melody, one array for the harmonies, and then the percussion. Each part gets its own array. So in Perl, this looks like, the data structure looks like this. I have a set of arrays containing notes, or notes and the given harmony, or simply a 1 and a undef for the percussion. And the player steps through that and plays or sends over OSC whatever it finds there. And yeah, that's basically it. The real code is just a subroutine that first generates a bass line, then generates the percussion. In my case, I use the one drop pattern for drums, which is a traditional reggae drum pattern. And then I generate a melody and return that pattern. And this is done for the verse, for the chorus, in the same harmony but a different melody. So we get a difference between the verse and the chorus, and basically that's it. And the player, it's basically these 5 lines of code or 6 lines of code. And we are already coming almost to an end. I haven't talked much about the Sonic Pi part. On the Sonic Pi side, I basically declare an endpoint for every kind of information I want to send to Sonic Pi, and also write a bit of code of how it should act. For example, the bass drum, I send 2 parameters. No, I send 1 parameter, the amplitude of how loud the bass drum should be, and it should respond to the /bd endpoint. And whenever a new message for that endpoint comes into Sonic Pi, I play the BD fat sample, which is a big fat bass drum sound with the given loudness. So that's basically all I needed to do. The modules, well, I use IO async, and I wrote net async OSC to send messages over IO async. These are not yet released onto CPAN, but will be once I get home. So there is one more idea, because, well, obviously now I have Perl and I'm not confined to Sonic Pi. So I can do speech output using Perl. It's not really hard, because you just create a Windows object and give it a string, and it has speech output. So I thought, why not do that, at least for the demo here, even though it deviates from my idea of dub, but at least it's not me singing, but the computer. So I added that, and I think I stopped.
We're no strangers to love. You know the rules, and so do I. A full commitment's what I'm thinking of. You wouldn't get this from any other guy. I just wanna tell you how I'm feeling. Gotta make you understand. Never gonna give you up. Never gonna let you down. Never gonna run around and desert you. Never gonna make you cry. Never gonna say goodbye. Never gonna tell a lie and hurt you. Thank you everybody. You are a wonderful audience. It's been a pleasure to sing for you today. Also, a round of applause for the band. Never gonna give you up. Never gonna let you down. Never gonna run around and desert you.
So thank you
Never
all
gonna
for
make
your
you cry.
attention and
Never gonna
Yeah.
say goodbye.
enjoy the conference.
Never gonna tell a lie and hurt you.